compound types. We saw union types where we go ahead and say that, hey, I want to keep track of a string or a natural number or a Boolean, okay? But at any given moment, I have only one of those. My value is exactly one of those three things, okay? So now we're going to go ahead and go to something that's maybe more familiar from your Java days, compound types. We'll call it a struct in Racket. In Java, class is the closest analogy. Sometimes I'll call this a product type. We'll come back to why I do that. Yeah, I want to go ahead and represent a natural number and a string and a Boolean. And I want to bundle them up all together. I want to encapsulate them. You'll remember from CS2 they talked about encapsulation and data hiding. I spent years before I realized that was not one big term. Encapsulation is making a struct. Data hiding is just all that public-private stuff, and I'm going to downplay that. Here, we're just going to talk about just the encapsulation part. Okay, so let's move on to an example and see how this is done in Racket. I want to keep track of books, and a book is going to be a title, author, number of pages, and whether or not it's copyrighted. Okay, so data definition. And here's what I'm going to do in Racket. I'm going to say, hey, in Java, I'd say I have class Java with 4 different fields. Okay, we'll do the same thing here. We'll call it a struct. Define struct book. And now I'm going to go ahead and say that, hey, I have a, what should I name my title for the field? If you said anything but title, ooh, you're just trying to get my goat, aren't you? What should you name the field for the author? Yeah, okay. Number of pages. You might have seen what I had up there and said, oh, I'll use sharp pages because Racket's pretty liberal about what characters it allows. It turns out sharp and comma are, and the apostrophe are the 3 characters that are a little bit, you want to maybe use in identifier names, but are reserved for Racket use. Okay, title, author, num pages, and is copyrighted. I can use a question mark, and that's awesome. I can use a hyphen. Again, one of the things you'll get from using Racket a while is a hatred of having to use camel case in languages that don't let you just use a hyphen in your name. Hyphens have been used to break compound words into components for hundreds of well, not hundreds of thousands of years, thousands of years. They're a great invention. Why throw that away? Okay. And for those of you watching this video and trying to nitpick it, okay, tick mark can be used in identifier names. It's just used in a special way, I think. Well, I don't know, actually. Never mind. Stop digressing me. We have a data definition for a book now. I haven't mentioned any types here. I should probably mention the types. I know that in Java, in my Java class, I would have had to label the type of each of these things. So let's go ahead and do that, and I'm going to come back to our final version, but I'm just going to sort of right now list the types of these 4 fields in the same order. So title, what type should we use for the title? I think string is an awesome type for that. Author, num pages. Your Java instinct says int. We don't want negative numbers, so we'll go ahead and say natural number, or nat num, or nat, or uint, if you want to sound C-ish and abuse that term a bit. Is copyrighted, Boolean. Okay, sounds good. I'm going to come back to this line and edit it, but let's go ahead and look at some examples of the data. Once I do this define struct book, this is actual code that says, it tells Racket book is a new technical term we're going to use. Well, it's the name of the type, and we're going to use it just in comments, but just like in Java, when you say class book, book is now a technical term in the rest of our program. So we can say make book title, the cat in the hat, author, Theodore Geisel. Number of pages. I should probably know this. Now with my son, I've read this many times in the last couple of years. Funny how you get different opinions on how good children's books are when you have to read them many, many, many times. Same with movies. Cat in the Hat, meh. Cat in the Hat comes back. That one is a winner. Okay, anyway. Is that copy? Yeah, that one is definitely copyrighted. Okay, so if this was the corresponding Java thing of class book listing our fields, then this is the corresponding calling the constructor. Make book is going to be the constructor. In fact, it looks like a function call, right? Make book, and then we pass it four things of that type. What type do we get back? When make book returns a value, what type do we get back from the constructor? A book. Book is now this technical term. So I'm going to go and actually make this part here. I'm going to go ahead and say make book and have a signature like this. Okay, so this will be my data definition, a defined struct, and I'll give the signature for the constructor. And that sort of, between these two, this sort of summarizes, I mean, this one gives me the types, this one gives me the field names. They're split across 2 lines. In Java, that'll all be on 1 line. Well, you'd probably put these on 5 lines or something like that. Okay, but yeah, okay, this will be our data definition, examples of the data. Notice that we're following the design recipe. It applies to all sorts of things, and I could do this in Java as well. Okay, so if I call make book, I said I get back a book value. How does a book value print out? Well, Racket's kind of nice in that the way it prints, it looks like nothing happened here. I called make book and I got back make book. It actually called the constructor, created the book object, and now it's like, oh, now I'm down in this little display window at the bottom. I need to print out a book object. How should I print something? How does the default toString work for structs? Hey, I'm going to go ahead and print it out in a form that you could copy and paste it and plug it right back into source code and have runnable code. That's kind of a nice convention that Racket uses. Dr. Racket, maybe. Okay, so great. We have our data definition and we have examples of the data. Let's go ahead and we'll look a little bit more at some of these. Well, let me add right now. Where did this make book get defined? Make book got defined when I said define struct book. When I said define struct, Racket went and built the constructor for me. Does that happen in Java when you say class book? Do you get a constructor written for you automatically without doing anything yourself? Yes and no. Yes, you get a constructor. No, it's not a useful constructor and you never want to use it. If you don't give a constructor yourself, Java makes one that takes in nothing and returns a totally uninitialized object. And I think the purpose of a constructor is to initialize all your fields. I never want to have in existence at any moment in time an object that is not fully initialized. So, and in Racket, the language helps me with that, helps achieve that. There's a lot of bugs I've seen in Java programs that are due to partially initialized objects, and people forgetting they're only partially initialized. So, okay. So in addition to, when we said define struct book, in addition to getting the constructor, we also got 4 other functions defined for us. 4 fields. What are those? The getters. Okay, so in addition to this, we can go ahead and, I'm going to go ahead and do this in the interactions window. I'm going to copy and paste this here. Here's our book object. It turns out if I want to go ahead and extract the author, there's a function for that. It's called book author. Book-author. That's the name of a function, and we pass it in an object. Copy and paste. Okay, so it's unsurprising. This is the sort of built-in primitive getter. What is the built-in primitive getter you have in Java? If you want to grab a field in Java, how do you do it? Use a special dot notation. You list the object first, and then you say dot, and then you say the field that you want out of it, okay? That's the primitive built-in getter that you were probably taught to always shield and for data privacy reasons, not export that as public. Yeah. Okay, here we're going to go ahead and treat it as any other function. So when you said define struct book, we went ahead and got make book, additional fields that were created for us. So define struct gave us a constructor and 4 getters. So make book, and we already saw the signature for that. Book title. What is the type of book title? Give me the signature of book title. Go ahead and pause the screen and write it out. Okay, what did you get for book title? Takes in what type? A book. And what does it return? A string. How do I know it returns a string? Oh, because I said make book. That second argument, our first argument needs to be a string. So book title and make book are kind of complements, inverses of each other. Make book is the constructor. It has four, together it has four inverse. The four selectors are like the inverse function of that. Okay, in some odd way. Okay, good. If you said here the book title takes in a string and a number and a boolean, you are not used to encapsulation. Okay, and I just want to stress this. The point of encapsulation is we no longer talk about a string and a natural number and a boolean. We use a new term, book. Okay, and we have in fact, that even distinguishes from other times when we might have all four of those pieces of information bundled together in some other type. That might also happen to be two strings, a natural number and a boolean. Well, but it might be a different type. So that's why we give it a name. So we have book. Okay. And we're going to say we pass around book. A function can take in a book. It can return a book. We never say, and will be how many things. If a function takes in a book, it will be taking in one piece of information. And if it returns a book, it's returning one piece of information. A compound piece of information. Yeah. That's the real breakthrough here. It seems silly to say, but the more you think on it, the more profound it is. This is one of the main tools of programming, is being able to bundle things together and call it one piece of information. It's no longer four pieces of information. It's one compound piece of information. Okay. So go ahead and book title is one of the functions created for you. I'll call it a getter or an accessor or a selector. Book author, you may have now guessed the names of the other things. And what's the type of book author? Yep, takes in a book, returns a string. Book num pages, takes in a book, returns a, if we're not sure, let's go ahead and again look back up here. Our data definition tells us all this stuff, okay? So writing that down, that data definition is important. You don't need to write down this stuff. I'm writing this down for you to be clear that when I do a defined struct, Racket goes and makes n+1 functions for me, makes a constructor and makes a selector, a getter for every field. And these are just regular old functions. There's no special syntax. You don't use a special dot syntax to call this function. You don't pass the object into the getter in a weird way like you do in Java. Same old, same old. Open paren, the function you want to call, and then the inputs to that function. Okay, like we saw down here. Yeah, so you got the idea. You can finish this out, no problem. Taking the book returns a boolean in that case. Okay, cool. There's one more function we get, by the way, and I'll call this the predicate, which is kind of a generic name, but we get a function called book, and I can pass in, pass in the result of calling the constructor here, and it says true, and I can say book of 37, and it says false. Can I say book question mark of the cat in the hat and Seuss and 37 and false? No, of course not. Book question mark takes in one thing, and we don't have four things. We have one thing, a book. Okay, awesome. Yeah, so let's go ahead and we'll come back in the next video and just continue on with the design recipe. We'll make more examples of the data, and we'll start looking at, we're going to skip the template and come back to it, and we'll start looking at writing functions that process these things.